For our next talk, Observability with OpenTelemetry. We have our speaker, Jessica Kerr. She is Engineering Manager of Developer Relations at Honeycomb. Jessica has been working as a developer and a conference speaker for over a decade. And then she has worked on KubeCon and DevOps days, go to KubeCon, some conferences. She is working in DevOps and different communities. Give it up for Jessica Kerr. She's joining us from St. Louis. Jessica.
All right. Ooh, that's really bright. All right. Today, I want to talk to you about a whole bunch of concepts in observability. But not everybody is here for observability. Don't worry. There's also a whole bunch of Kubernetes concepts in this talk. Really, this is the story of software maturity, where you might start with an app. For this example, like to get the material for this talk, I started with the Spring Boot Pet Clinic. Anybody heard of the Pet Clinic? Yes, I knew back in what. So this is just a standard example app that people have forked a zillion different ways online. Now, I wanted a version that did not have any observability yet, so I forked the base version. I made one change, that is my cat instead of their cats. All right. So, so I forked the app, and then I want to get it running. I could run it locally, but that's boring. As for our software matures, we have different ways of deploying it, right? So first, Docker builds your app into a container image, push the image up to the image repository with the repository image name and tag it to the container definition, and now we're into the YAML. The container YAML goes inside the pod YAML. The pod YAML goes inside the replica set. The replica set goes inside the deployment YAML. And now we can kubectl apply, but don't, because deployment does not make an app. The deployment YAML goes into a Helm template. The Helm template goes inside a Helm chart. Push the Helm chart up to the chart repository. And now we can Helm install. But no, because we're still not in infrastructure as code. So the Helm release goes inside the Terraform. The Terraform provider adds the Helm resource, and the Terraform to my Git repository, and now I can finally save it. Yay. All right, so just make my app a proper deployment in infrastructure as code in Kubernetes. I have used all of these concepts already. As a developer, it's like, oh my gosh, it's kind of a lot. Especially when you don't use it very often, and you have to look up every time, wait, is it Docker LS? No, it's Docker PS. But the good part about this is that as an app dev, I'm thinking about more than my code. I'm thinking about my app in its runtime environment. And observability is kind of the next step in this, an important next step, lovers. But I also want to know, not just, does my app work on my computer or in CI, but is it working? Is it actively working in production? And if not, I need to find out what's wrong. And then I can care about whether it's fast or what's making it slow. And historically, this has been divided, of course, between dev and ops. And the ops care about the forest, right? The people running or operating all of the applications. They need to know about this fleet of application, all the pods on all the nodes, and they need the shape of the forest. And so they don't want to miss the forest for the trees. The logs aren't like the trees, they're more like the leaves on the tree. Because they're small and it's like the leaves but disconnected. And so this historically has been how app devs knew what was going on. And it's not good enough anymore because I care about my app in context, in its runtime context, in the context of all the other services. So really what we need for good observability at the application level is more like I need some of the trees and I need the shape of the forest. Where the tree in this case is a user experience, if the users, like a web client. So the whole story of a request that came in and went through all the different microservices on the Kubernetes and everything else they're doing, the databases and the queues. And so I want the tree to be the whole story. And it turns out that it's really useful to have some of the trees, that's a distributed trace in this case, we'll get to that later, and also the shape of the forest, because you need to know, all right, something's wrong, some trees are sick. Okay, what kind of tree is sick? And then you go look really closely at one of those trees. That's what we need. Okay, so this is, I'm calling this observability. To be fair, I work at Honeycomb, and our CTO, Charity Majors, is the one who brought observability into use in software, which doesn't mean we still get to decide what it means. But observability is about being able to see into your software because it's telling you what's going on, not just, okay, what outputs does it already have, and let's look at them. But what outputs can we make it give us? And that output is called telemetry. When observability was a word in rocketry, this is where we get it from, and other engineering. This is like, if you have a missile flying across the sky, you don't know how fast it's going because you've got like some sort of police radar airplane chasing it. You know how fast it's going because it tells you. And that data is called telemetry. It's just for us as operators, it's not user data. Telemetry comes from instrumentation. Instrumentation is a piece of code that just sends this useful data to us. We already have a lot of instrumentation. Even a log statement is instrumentation that is giving us some information. Logs and metrics are our information. It's just, are they the best information that we could possibly get if we only had control of our app code, which we do. All right. Another concept that we're going to need, another thing that we need to trace a tree and not just a bunch of leaves, is propagation. And propagation is when there's not just one rocket in our software systems, there's lots of them. And when they're passing requests along, they need to pass some context so that we can build the causal chain of why we did each thing because it was triggered by a call from here, from here, from here. So propagation, we'll see more of this later, but this takes the form of HTTP headers, gRPC, metadata, messages that go with the message in order to see where it came from. All right, so now we've talked about these concepts. Let's add some more. These are going to get us to distributed tracing. All right, how many people are comfortable reading a distributed trace? Okay, I see like 4 hands. Okay, great. I have an excuse to go through this part. Because it's not trivial. I mean, logs are simple, right? They're strings. We have to do a lot of work to piece together which strings go with which and what each one implies, but it's different. So if you start from logs, say this is a checkout request coming in some sad little e-commerce app, you're going to log when you receive the post and maybe log something about what you're doing, and when you call into the service, maybe you can log when you call the database, and so on. And then similarly, when you get responses from those, you'd have a log. To turn these into distributed tracing, first, we're going to make like a graph of these. Each one knows which other call caused it. So we've got this little tree now of what happened what. We're piecing it together. And you know which service sent this, so we can piece it together across services. That's handy. And then, we don't just know that each of these happened. We know when they started and when they ended. So each of these rows here is called a span, because it represents some span of time, some unit of work, and there's a timestamp and a duration. Now, this means that somewhere we're holding state, because we don't send the span, we don't emit the telemetry until it ends and we know what the duration was. Along the way, we can accumulate more information about it. In the meantime, we're sending our span ID down to the services we're calling so that they can say who their parent span is, and we can build the tree up later. Okay, and then when there's an error, you can see exactly where it is. You can see, like, I don't know, which branch is falling off the tree. You can locate that really fast in what service it is, instead of different teams fighting with my logs versus your logs. It's just right there in context. And then there's all this other stuff. you put the status on there, you put the messages, you can put CPU and memory on there. If you're running, oh, did this fail because it was out of memory? We'll put the memory on there and you can notice the trend. Lots of things you can add on to these, and it's still like each span is one event to send. It's a lot of leaves on here, except they're like tagged together. If you were doing this in logs, you'd have like at least that many, because you'd have starts and ends and the in-between information. So a distributed trace contains everything logs do, and then some, and it fits together better. So that's like really good. It's really good for debugging applications in systems, and that's what I'm going for. But it's kind of a lot of work. There's a reason that we emit logs. It's because they're easy. I can send a string to standard out, and anybody can pick it up. Logs are super compatible with everything because in the end they're just strings. Might be structured strings, but they're still strings. So we need some help. There are various vendor tools that have been doing this for a while, and
That's fine.
thanks. But you need this to be a lot more standardized than logs. Everybody's got to send and receive that propagation the same way. All of these spans need to go to the same place so that they can be reassembled into their tree in the waterfall view. We need some help with that. And enter OpenTelemetry. So OpenTelemetry is the second biggest project by contributions in the CNCF. The only one bigger is Kubernetes. So it's a big deal, and a lot of people are using it. It is the industry standard now. And its job is to make this kind of observability, also logs and metrics. It also does logs and metrics. But the biggie is the distributed traces that we couldn't do before. Its job is to make these available to everyone and give you open source code that does this and not tie you to a specific vendor. All right. The way this works, you've got these green boxes. They're not very green, are they? Whatever. These bigger boxes are your application, and your one app is calling your other app. It's kind of database, whatever. We need both of them, these, to emit telemetry, to send spans that will become parts of traces. And we need them to do that in a standard protocol. So OpenTelemetry governs the specification for the OTLP protocol. It stands for OpenTelemetry, the L is silent, protocol. I don't know why they call it that, but it sounds good. And so we've got the OTLP traces, metrics, and logs specifications. And then also the propagation has to be standardized. This is even at a higher level than the CNCF. This is W3C, has a standard for what HTTP header to use for this. And then there's other standards for gRPC and other formats. So we need these things to be standardized. And then the magic of OpenTelemetry and what makes it a huge project instead of just a committee defining a standard is the instrumentation. Anybody can write code that emits spans in OTLP, but nobody wants to. So there's libraries available in every major language and a lot of other languages too, like a lot. So there's like, this box here, just orange on this projector, represents the OpenTelemetry libraries for exporting and sending, buffering, and matching up the spans to send, and the metrics and the logs. And then there's all these other libraries that actually, okay, whatever, these littler orange boxes that are inside the gray boxes represent automatic instrumentation that plugs into your frameworks. So it plugs into Spring, it plugs into Django, it plugs into Fast API and Cowboy and all the other web frameworks in all the languages, so that it does the propagation for you. And also it's like, oh, you received something, you'll need a span for that. I don't have one in the header, so I'll start one, a new trace. And then it passes on the propagation, and then both the servers and the clients are instrumented. And also like things like database clients and various other libraries, Redis, and lots of existing libraries have like these add-ons as part of OpenTelemetry that like get inside them instrumenting a bytecode in Java, or interfering with the require in Node. They do sneaky stuff to add the instrumentation for you. And that way, you can get a lot of this with very little work. We talked about those things. Now let's put it in Kubernetes. Get some more Kubernetes concepts in there. Because that automatic instrumentation, we still need to get it into our code, even if we don't have to write it. And there's magic for that. Okay, so here's my app in its container, in its pod. Enter the OpenTelemetry operator, which you can install with the Helm chart, or with a very scary kubectl apply this downloaded YAML. Yeah, no, thank you. But the Helm chart I can live with. I can do a dry run on that. Okay, so there's the OpenTelemetry operator, and it does things like define custom resources. One of them is instrumentation. So I created an instrumentation resource that says, okay, Java instrumentation is a thing in my cluster. And then I added an annotation to the pod template in the deployment YAML. And you can also do this at the namespace level, so you can get all the pods in a namespace at once. And then the operator, when the pod starts up, so I have to restart my pod. The pod starts up, the operator gets a turn, and it gets to do this magic thing of injecting another container into the pod, and it's like this init container that starts up, shoves the automatic instrumentation into the app, and then shuts down. And suddenly, I have tracing. So you can get tracing like magic throughout your whole app, through everything in the cluster. Oh, I forgot to list the languages. This works for Java, Python, .NET, and Go, at least. The other languages take some per pod work. But if you have like Java microservices or .NET, woof, and then I get tracing. So what this looks like is, here's my pet clinic app, and I went and I just get this page. I'm viewing a pet owner. And then I went and looked at the trace. Here's the trace in Jaeger, which is an open source tracing tool. This is part of the CNCF as well. And you can see a bunch of spans and their durations, and you can see some things that took longer than others and some things that happened in serial. And it's a little hard to read, but it's doing things. There's some select statements that were database calls. Okay, here's the same trace in Honeycomb, which I just wanted to show you the library names. So the library names are the different automatic instrumentation libraries from OpenTelemetry. And there's some for WebMVC, and there's one for Tomcat. Okay, so there's your web clients. There's JDBC and Hibernate and Spring Data. So you can find out what the hell Hibernate did to your database. And the actual select statements are in there on attributes if you dig in. And that's cool, but this is only one service. My Spring Pet Clinic is lonely. If I instead look at a trace from the OpenTelemetry demo app, which is a gratuitously complex microservices app designed to show distributed tracing, then there's a whole bunch of different services. Okay, on my screen, those spans change color, but trust me, there's a whole bunch of different services and those change color, and so you can see the flow of this checkout through currency service and payment service and shipping service. And then when there's a problem, you know exactly where it is, you know who to talk to, and if the problem was from bad data from upstream, you know who that upstream is. Very useful. All right, so that's distributed tracing. Also, when you click on any of these spans, you get a bunch of attributes, like a pile of attributes. The automatic instrumentation is going to put some attributes on. It knows you want the URL. It knows you want target, scheme, method, host, client IP. Those are easy. But it's not going to put your post body, because that could be PII. It's not going to put headers, because who the heck knows what weird stuff you just shipped around in there. You need to add that yourself if you want it. So automatic instrumentation gives you the scaffolding, it gives you the structure, but then a little bit of custom instrumentation, and this does involve actual code because it's specific to your app, goes a long way. So in the demo app, they've added things like shipping tracking ID. Oh, that's useful. Now you know whose package just failed. And order count, because maybe it's only large orders that are failing. And if if you have that information, you can figure out that it was that kind of tree. So this adds a ton of value to your traces. And then there's some Kubernetes specific fields. These get added to everything. And that's not actually happening in the automatic instrumentation, it's happening later. And that gets us to the pipeline. So after your app emits this telemetry, where does it go? Well, it's gonna wind up in a database at some point. But on the way there, you can do all kinds of things with it. So it's typical to run some sort of telemetry pipeline, meaning everything between the apps and the database. Some sort of telemetry pipeline to like configure and tweak and sculpt your observability data. All right, so that gives us a whole bunch of concepts. Typically, your pipeline will be composed of one or more, probably more, OpenTelemetry collectors. So this is another piece of the OpenTelemetry project in the CNCF, and the collector is kind of the Swiss Army knife of telemetry, of OTLP and everything else. So inside of it, it's got some number of receivers that take in data. It can take in data in OTLP, of course, but also in the historic Jaeger and Zipkin and OpenCensus and OpenTracing format. It can scrape your Prometheus endpoints, and so it's compatible with everything. Also, it can send out in any of these formats, so it's compatible in both directions. And it can send out in multiple ones. And in between, it can filter some data if there's stuff you don't want in there. It can add these Kubernetes attributes. It starts from like an IP address or something, and then it uses some Kubernetes APIs and magic to add the pod name and the pod IP and all of these other things that you might need to know. Is it a node problem or a pod problem? You want that stuff. So those Kubernetes attributes actually come from a processor and the OpenTelemetry collector. Okay, so it does a lot of things. Compatibility, you can filter data if you're worried about PII, you can send to multiple backends, you can send to your local instance of Jaeger, and also your observability as a service in the cloud, and it can scrape data. Some of these receivers are actually going out and gathering data, and that's kind of like the screwdriver part of the Swiss Army knife. You don't want the screwdriver and the knife out at the same time, so that's why you might want to run multiple instances of the collector. More reasons. Okay, so for your standard knife in the Swiss Army knife of passing OTLP through to the back end, this lets you configure your collectors with where you want to send it. Your apps don't care, they just send to a service. That's the easiest thing. You can even add an ingress in front of it and send from the browser. That's handy. Or you can go to another extreme and run a collector in every single pod as a sidecar. And if you want the sidecar, the OpenTelemetry operator is your friend because it does that magically. But meanwhile, you could also compromise and use a daemon set. And this way, your apps are able to send data locally on the same node. And you definitely want a daemon set to do the scraping from each node because it can give like the kubelet stats and file logins or per node things. So you want a collector per node doing this. You also want a collector per cluster scraping cluster related things. So all of these are described in the getting started of the Kubernetes docs, OpenTelemetry.io. But the goal is you've got these Kubernetes metrics, and you've also got your application metrics and traces, and these are like correlatable with each other because they're all going to the same place. I really tried to make these graphs in Grafana, but I cannot keep Prometheus running. It's just demo mode, and I still couldn't do it. It's fine. I had to show you this in Honeycomb. Software as a service. Yeah. Okay, and then there's 16 different ways of deploying the OTel collector, which I'm just going to give you the TLDR on that. If you really want to use a sidecar, the OpenTelemetry operator and a custom resource are your friend. You could use that custom resource to run any of the others, but it's easier to use the Helm chart because then you get a bunch of Kubernetes presets that write the configuration for you. There's, of course, a lot of configuration involved, but it's all in the docs. Okay, and then the other thing is you probably don't want to use the generic collector image that is the Swiss Army knife with all the tools. You probably just want to build in the tools you want. So that's recommended. You can look in the OpenTelemetry collector repo in the OpenTelemetry GitHub project. And then you'll also need stuff from Contrib. Most stuff is in Contrib. Completely different levels of stability on each of these. These are some of the exporters and the receivers. And you'll notice that all these receivers start with A, because this list just keeps going forever. Yeah, so there's something for everything, but you have to check each of these individually for like how many maintainers they have and stuff like that. It's the same with the language SDKs and auto instrumentation. Java has the most contributors, super stable. The other major languages are really good too, but if you get to like, okay, PHP is a major language, but it's not the most supported in OpenTelemetry. Ruby's good if you're on a recent version. But in general, OpenTelemetry is a zillion projects, and the instrumentation libraries vary, but the APIs are super stable, and they're built on top of an API specification that's common across the project. What's not super stable is the semantic conventions of what should we call the fields that everyone sends, because that's a bike shed. It doesn't matter, and so we argue over it the most. Right, so we talked about those things. And I want to get to this other part of I've been skipping over this part, this database bit where you save all your telemetry data. That's actually really important. OpenTelemetry calls it a telemetry backend, which is confusing because it's also a front end. It's the really important front end that determines the entire developer experience, and everything you get out of all of this is determined by how well you can query that data. And do you have the trees that you need? And can you still see the shape of the forest? So which is actually super important. But OpenTelemetry means that you don't have to make a decision about that now. Step 1, use OpenTelemetry. Step 2, choose a backend. Step 3, choose a different one. Step 4, choose 2, whatever. You maintain control, and that's important because this stuff, the pipeline and the instrumentation, this is in your code. This is in your network. And you should own it and control it, and that should be open source, not a vendor, agent, and libraries. On the other hand, your backend is stateful and is a database, and you absolutely want that to be in a different network, I mean, at least a different cluster, a different failure domain specifically, because if this is all corked, you really need this to work. So you should have a different failure domain for the backend as in the database and all the querying functionality there. That can be software as a service because you need it separately anyway. And because it doesn't have to run in your network, and it doesn't have to be in your code. Oh, and it's stateful, so it's way the heck harder. I can't keep Prometheus up because it runs out of memory, because I haven't given it a persistent volume, because I don't actually care. Yeah, the stateful stuff is way harder to run than collectors and the services you already do. So another reason to keep it separate. There's a bunch of considerations, but I don't know how much time I have. I don't know when I started. Cost is a big one. Charity, our CTO, says that your observability infrastructure and tooling should cost about 30% of your compute infrastructure. That's a lot. It's a lot. This is expensive, but it gives you the ability to make your software work, to make it faster, to keep it running, to respond to incidents. It's really important. It's a lot easier to do something than to prove it, and the observability lets you prove it, that it's working, and that people are using that feature that you just spent all month crunching on. So to save costs, with metrics you have to reduce cardinality. That's really painful. You can't have a metric per container, or you can't have 6 metrics per container. That just multiplies the cost. But traces, I mean, yeah, you put the container ID as an attribute, they don't care. The trick with traces is to sample, is not to save every tree in the forest, but to save some of each kind of tree. That's really complicated to do, out of scope of this talk, but it is a thing, people do it. That's how you save money. It's different than with logs and metrics. Okay, for performance, yeah, build your collector. Put the the whole operator thing that jams in the auto instrumentation is a great starting point, but it does affect the startup times of your apps, which you probably care about. Import those libraries directly and import only the ones you need instead of the kitchen sink, like the auto instrumentation gives you, and you'll have better performance. Also, that helps you with adding the custom attributes. For that, you only need to depend on the API, but that gives you way more value and should cost you nothing, or very little. Security, build your own collector images to reduce your surface area, and you can do some filtering in the collector. Your traces are probably not your major security tool because you are sampling them, but they can be useful for stuff like, as a developer, I want to make this field validation stronger. What the heck do people put in this field? Observability is great for that kind of thing. Upkeep, of course, this is a big part of the cost. A lot of enterprises these days have an observability team. If not, it falls under platform. Somebody's got to operate the pipeline. You can't outsource that part. Internal libraries, if you have internal libraries for like networking and calling the other services, great place to add your own instrumentation and get it everywhere. The backends, the actual stateful databases, are really expensive and painful. This is where day 2 is really a pain, because upgrading anything stateful is way harder than upgrading a collector that can just flush its buffers and then restart. Overall, both Kubernetes and OpenTelemetry and the CNCF in general represent maturity as an industry. As an industry, we're growing up and we're providing these things in ways that are standardized for people. And as a developer, do I really need to know all of this? Well, hopefully not. Hopefully I need to know about this much. I need to understand distributed tracing. I need to know about deployments and my runtime. But maybe the rest I can leave for my platform team and consult them when necessary. So I'm still going to need the support of people who know about all the things and how to troubleshoot them and how to fix them and how to use the logs to get the traces working. But what I need to know as an app dev is I really need to care about my app and the business complexity that's adding value, which includes being able to run in production and the dependencies on all the software that I need to get my business stuff done. I need to know how to use the observability tool. But the platform team can choose that and can run the pipeline and make it easy for me and be there when I have questions. So as an app dev, I need to be able to look at my little piece of the big overall trace and see it in context. And I need to be able to see that in the context of Kubernetes and the nodes and the pods, so that I usually don't have to care about pods. Pods don't matter until users aren't happy, and then they might matter a lot. So thank you for listening to me talk about all the things. And here's a barcode with more resources to sign up for our newsletter. Thank you.
Thank you, Jessica. Maybe we can take a couple of questions. This microphone over there.
I think that was 35 minutes. That's pretty good.
Thank you. That was really cool. And I looked up the Ruby auto instrumentation docs on Honeycomb, and it looks like it actually goes all the way back to 2.5, which is pretty cool. I have a question about OpenTelemetry collectors. As you mentioned, running that big database wherever it is with all your data is like the most impossibly expensive part of anything. I'm really interested in APM and auto instrumentation to kind of view like, where are my slow queries, what transactions of mine are the worst. And you touched on filtering at the collector level to kind of aggregate that stuff and send less to your backend, so you maybe spend less money on your backend when you're querying it later. For me, like the really important things I want to get out of my auto instrumentation is like my percentiles. Like show me some of the 99% worst spans, the 95% worst spans.
When you're sampling, if you do tail sampling, that's the word for it, you can also be like, keep all the really slow ones. Keep all the ones that failed.
And I can do that at the collector level before I send it back to my backend?
So the collector has a very alpha implementation of tail sampling. Tail sampling is harder than random sampling. Random sampling, you can just decide, oh, I'm starting up a tree. Should I send it? Yes, no, no. I don't even bother making the spans. But then you lose some errors and moments. Tail sampling is, okay, we're going to make the spans for all the traces. Then somewhere inside the network boundary where it's not too expensive, we're going to accumulate those in memory. And then we're going to wait till we think we can probably have the whole trace and make a sampling decision. Send it, drop it. And so that's hard. You can't usually do it in one process. That's too much memory. There is an alpha version of tail sampling in the collector. I don't know how far it'll get. At Honeycomb, we have Refinery, which is an open source project because you have to run it in your network, and we're not going to ask you to run anything proprietary. But we have a very fancy sampler that's super configurable, so you can be like, okay, send me one, or at least one trace per half hour for this endpoint and each tenant, maybe, if you're a platform as a service or something. But to also send me all the errors, also send me all the slow ones. And it can make really smart sampling decisions. And the other crucial thing about sampling is that for every one it keeps, it knows how many it dropped. So if you said, okay, for each endpoint and region maybe, try to send me 1 out of 10. Then it's going to tell you, okay, I sent you these, each one represents 10. And then in the graphs, you can reconstruct that, whereby you, I mean your observability tool, you shouldn't have to think about it.
Honeycomb Refinery is the name of the tool that I run on my site to do that?
Yeah, if you're using Honeycomb, one of our distinguishing factors is that we have Refinery and we support it. It's not the easiest thing to run, not as easy as a collector, because it's stateful. But short-term stateful, you know, I want to keep a trace for 5 minutes, and then it's like, send it or don't, we gotta decide. Yeah, tail sampling, it's complicated, but it really lets you tell the story and keep the shape of the forest without trying to keep every tree.
That's awesome, thank you very much.
Thank you.
All right, any other questions? Thank you, Jessica, so much. That was awesome.
I was just curious, you had a kind of a sample dashboard looking thing in your presentation, and on one side of it, things looked kind of spiky, and then there was this thing just bouncing up and down steadily. Is that an actual meaningful dashboard, or was it just kind of something ran for 5 minutes to gather some data?
Oh no, that's the pet clinic, and those boingy things are all health checks from Kubernetes. It turns out that just running this thing in Kubernetes is pretty expensive because all the health checks from the AWS load balancer and from the service, and those are health checks. And at some point I restarted it and did a bunch of database things. Yeah, that was the crap, yeah. Also, the metrics that I measured are the first ones that I found.
So if you actually saw that in a production app, you'd look at that and go, maybe something needs to be fixed, or?
Actually, I would increase the granularity on the queries to smooth out the line. Because if it's doing this, you know, it's getting so many requests every 10 seconds, then I want to look at it on a minute basis.
Thanks.
Cool question.
All right, thank you. Sorry, I didn't see you there. All right, thank you so much.